Okay, so I wanted to show you this problem because it has a unique feature that a lot of people, it kind of bothers them, so I wanted to show you an example like that. You'll notice that it's, again, asking for 4 elements, so I'm going to mark those as best I can. Let's see where they are. So FG, that's here. DG, that's here. Oh, this is looking promising. CD, oh, look at that, that's there. Look at that. How convenient. That means I could cut the structure right there and get 3 of them, right? And GA, what's up with that? That's down here. We may have to come back for that one later. Right?
Yeah.
Let's consider that at the end after we have what we have. So now I like this problem too because I think it's clearer of choice. If I'm looking at a cut here and I'm trying to decide if I want to work the top half of the structure or the bottom half, I think there is a clear choice. All right. If you work the bottom half, which is okay, you've got to find 3 reactions before you get started. If you work the top half, you don't have to do that. So I can just plow right into a free body diagram of the upper part and look at 1, 2, 3 unknowns. So let's do that first. So I'm going to come over here and kind of sketch out somewhat of a free body diagram for this thing. So that will give me a force in FG and a force in CD. I think I'll put this one in there to make it not look so lonely. And a force in, what is that one? DG. So using our strategy that we had previously, let's see if we can identify some points where a couple of our forces are concurrent. Again, looking at your subscripts will help out. See, I've got DG and I've got CD. They share D. That's a good place. What else do I have? Got FG, DG. I didn't leave myself enough room here, but I'll kind of show you that, yep, there's another point G. Those go through that. Any other point? There's one kind of slightly hidden that you can't find from just looking at the subscripts. E. Why would I go to E? Well, you'll notice that FG passes through E and CD passes through E. And I'm just left with one unknown. So I can actually write 3 moment equations for this problem. And you know what? I will. Which one do you want to start with? We got E, D, and G. Want to go with E first? Why not? So let's sum moments about E. Oh, it's another me. Me equals 0. Cool. Now, if I do that, how am I going to handle this force? Well, remember, and I'll try to exaggerate it here, that force is valid anywhere I want on that line of action. I can slide that guy, any guy, it's not a male force, it's just a force. I can slide that force, it, up and down that line, anywhere it wants to go. Where should I slide it so it helps me out the most? I think G is a great spot because if I slid it down to G, I would have a vertical component and a horizontal component, right? Which one of those components creates moment about E? The horizontal. So now I need to find out what that the slope of that line is. So that's this guy right here. So it looks like it has a run of this dimension. What's that dimension? Well, it starts off at 3, and it goes 3, and it's halfway to 0. So that must be 1.5. And then this is 2. Guess what? It's a 3, 4, 5 triangle. 3 in the the horizontal, and 4 in the vertical. So my horizontal component will be 3/5 of that. And in this direction, what kind of moment does it create about E? I'm using right-hand rule for my sign convention. I heard both. Let's vote. You guys want to vote, right?
Yes.
We talked about this already. So who thinks it's positive? Raise your right hand. Oh, just like normal. You're not voting. How about the other one? Who thinks it's negative? Raise anything. Oh, nice. Let the record show it's almost unanimous. So what was it again? Positive or negative? I lost track. Negative. Okay, so it'll be negative, and the horizontal component will be 3/5 of dg. And what's the distance from G to E?
4 meters.
4 meters. What else creates moment about E? Well, I forgot that there is a applied force of 4 kilonewtons to the left at E, and an applied force of 4 kilonewtons to the left at F. Do any of those create moment about E?
The one at F.
Yeah, the one at F does. What kind of moment? Positive or negative?
Negative.
Negative. So that'll be negative 4 kilonewtons is the force. And what's the moment arm? The distance from E to F?
2 meters.
2 meters. I think. Is that it? I believe so. So we should be able to solve for the force in dg. It looks like it's 3.33 negative. And that would be kilonewtons. Does it make sense that dg is in compression? Well, look at all these forces. They're all moving the structure to the left. It's going to try to pivot about A, and I believe as the structure tries to move over, this element would shrink and compress.
Without the equation at E, is there another way to find all three? Or would that be too hard?
Well, we can write 3 equations and 3 unknowns and not really pay attention to what we're doing, but you'd probably have to solve them simultaneously. The advantage of this technique is that I had to think and write my one equation, but it's one equation and one unknown, and I may not have to use that value again. Because if we follow our strategy and now go to another point that we picked, which was, what other point did we pick? We have D and G. Which one do you guys want to do next? G. So if we sum moments about G and make sure it's in equilibrium, what do we deal with? Well, here's G. So I got DG and FG are passing through that. So how am I going to handle CD? Again, you can imagine that guy, it can be anywhere it wants to be along its line of action. Where should it go? Probably the best place would be to slide it all the way up to E, right? Where just, again, the horizontal component would create moment about B. Or you could slide it all the way over to, I'll sketch this in so you can see it. You could slide it over to C, which I think is what I will do. And then I'll have a vertical component and a horizontal component. Which one creates moment about G? The vertical component. You see that? And what is the slope of that line? It'll be the slope of this line here. So again, that's half this distance. The run is half. Half of 3 is 1.5. And the rise is 2. So again, it's a 3, 4 triangle. So I have some moments about G right here. Again, these don't make any difference. This guy, I want the vertical component. The vertical component is 4/5, and about G, does this component create positive or negative moment? Negative. So 4/5, the force of CD, and then when the moment arm is the distance between G and C, which is 3 meters. So there's the effect of the vertical component of CD about G. Who else creates moment about G? Both my forces. And they are going to create positive or negative moment? Positive. They both have the same value, so I'm going to factor that out. So there's the force. One moment arm is from G to F, which is 2. And the other one is from G to E, which is 4. So let's solve for the force in CD. It looks like it's going to be positive, and it's going to be 10, I'm guessing. Is it 10?
Yes.
Wow, good guess. So what's left? We're going to sum moments about D. Now the reason we're doing this, you might think, why am I doing it this way? I could write these equations in any order I want. It won't matter. It doesn't matter that I don't have to do E first, and then G, and then D. It doesn't matter. They're all independent of each other. You can do it any way you want. But looking at D, you can see that DG and CD pass through there. So all I have to worry about is the moment of FG, and it's all vertical, so I don't have to worry about components. So about D, FG creates positive moment. So I've got the force in FG times its moment arm, which is this distance right here, which is, we already looked before, it was 1.5 meters. Then who else creates moment about D? Not this force, right? It passes through D, so it would just be this 4 kip up here, and it creates what kind of moment? Positive or negative? Positive. And what's the moment arm? 2 meters. So it looks like the force in FG is going to be negative, or compression, and whatever 8 divided by 1.5 is. Anybody know what that is? Huh? 5.33. Cool. Now what? Yeah. It's this guy right here that's messing with me. What do I do about GA? Oh, no. I don't know. What do you do? Well, let me ask you this. Could I do a method of joints at G? Yeah. Well, I already know GB, and I know FG, and if I sum forces in just the vertical direction, I'll find this. This guy's horizontal. I don't care about that. That sounds like a fine plan. So let's do that. So let's come down here and do method of joints at G. So there is my G. We've already found a value for the force in FG and the force in DG. There's another one that I'm not interested in right now that would be to the right. That would be the force in CG. And then the one I'm looking for, which is the force in GA. And just to make sure I have everything, I'm going to go ahead and figure out what my angle is here. But I think I already did that. There it is. It's 3 to 4. So I'll just make sure I write that in. I think that's all I need. Also, just to remind myself that I already have found that value, and I've already found that value. Sorry? What? Huh? Okay. So now we're going to sum forces in the y direction. Now this is the most dangerous equation we wrote because it's going to include two computed values. Could be an issue. So we'll start. Looks like GA is down, so that'll be negative. GA. FG is up, that's positive. And then I just want the vertical component of DG, which is 4/5. So that'll be up 4/5 of DG. Oh, I did forget that there's a 4 kilonewton force here, but I'm summing forces in the y direction, so it's not going to matter. So I should be able to plug in FG here and DG here, and I should be able to solve for the force in GA. It looks like it's going to come out negative. What do you get? 7.9? Anybody else get 7.9? All right. And there we go. No problem. So that took about 16 minutes to do, including a session on voting. So we should be okay. So any questions about that? All right.